Hi, I'm Andrew Armstrong and welcome to the Backfist Teardown Lab. Today we have some sort of noise making kit, and this is one of those cheap kits, not like the Velleman kits that we've been doing recently. It's the cheap kits, i.e. the ones that come with no instructions whatsoever. That's okay, we'll probably figure it out as we go along. Well, first things first, I can see a potentiometer and headphone socket. Those we can leave out till the end because we can't get that wrong. And then we have a couple of actually quite nice screw terminals. Totally unexpected, to be honest with you. So there's a couple of ICs. In fact, there is 4 ICs. There should be 4 ICs. 1, 2, 3, 4. Yeah, there we go. In my brain I only counted 3, so I had a little panic attack there. We've got a few small capacitors and then a bunch of resistors. So I'm going to start by organising the resistors and we'll start populating this board. Having been through this, it's not going to be too bad actually. I think even without a knowledge of the resistor colour bands, or like me using a meter, you're going to be okay because the numbers of the components make a lot of sense. So you've got 3 here, and I've counted 3 100k resistors. You have 2 1 meg resistors, and then you have 1 10k and 1 470. So you really only have to worry about the 10k and the 470. So I'm just going to poke those through. Now those are a little bit tighter actually. I'm going to try again, but they feel like they're a little bit tighter than the most common gauge on here that I use. I'm going to go one down. In fact, it's off the gauge when you do that, but I think that's, yep, it's got a little bit of a nip in it, but it does mean they won't fall out. So I'm just going to chuck those in. If you've got these at home, you can see, just print yourself off a gauge. I don't know if you can buy them, I'm sure you can. So you can get them all nicely bent. And that's handy, look, you can do quite a few. And then you can pull off the little mounting paper and then just post those through. There's nothing much to it. We're going to save those transistors for the end because I'm going to want to make sure we're using the right ones in the right way. And again, I'm assuming they're transistors, but we'll read the numbers off as we get to that point. No circuit information whatsoever, of course. This is a nice little kit. I should think this is a 10-minute max kit, which if you're busy like me, that suits me down to the ground. Just posting that in, and we have one more 1 meg. You can see what we're up to. Appreciate you might be like me with a 1080p telly or a 720p actually. You might not see all those details. I really should start switching the camera to 4K, but do we need the 4K really? I don't think so. And while we're at it, let's get that potentiometer in there. It says phone volume. Phone, I presume it means a phone. And that's a bit loose, but we'll probably just get away with it. So we'll flip it all over and we'll start that soldering process. And we're going to use, I've got a tiniest amount of leaded solder left, but I don't really want to use that up because I'm keeping that for special occasion. So we're going to use unleaded. And unleaded is pretty common. It's the most common now you get, so there shouldn't be any problems with that. And I'm just going to flow it in, taking care not to jiggle those resistors around too much because I don't want them to fall out the other side. And let's hit that headphone socket. Give it a little bit extra, and I'm going to just turn it over and make sure that that's sitting flat. It is. That's sitting flat. All the rest are still flat. Nothing's too disturbed. So we can just carry on and get all of the remaining pads soldered. That was not too bad at all, actually. Nice quick little job there. Oh, and these legs are nice and thin. It's not putting too much of a strain on the old side cutters. Unfortunately, I have broken some recently by abusing them, so I really don't want to break any more. I don't have too many spares. Let's have a look. I know I said I'll save them to the end, but let's have a look at these ICs. So we have a 9014, 9014, 9014. Are these all the same? 9014. Okay, great. They're all the same. That's pretty easy. 9014. Not quite sure what that is. Perhaps it's a transformer. And by transformer, of course, I mean transistor. I've got transformers on the mind today. Been thinking about Optimus. How they killed Optimus Prime to sell a new line of toys, but then they end up bringing him back, didn't they? So those 4 are in. Now, if this is some sort of white noise generator, because hazily I remember something about a white noise generator, they could be used with the appropriate input hardware, analog to digital converter, as a random number generator. And you could write a nice little kernel driver, or to be honest, even a user space driver linking to /rnd in Linux, and you would have your own random number generator, which I don't know if that's a good thing or a bad thing, but it could have lots of random entropies. Such a thing could be important for encryption systems. Okay, that's those. Let's clear up those legs. I'm not even going to let go of the soldering iron. I think we're just going to keep rolling now at this point. Super near the end already. So we have a few ceramics. We have a 10 microfarad. No, tell a lie. We do have a 10 microfarad, but that's an electrolytic. So you have this 104. You have another 104 going in there. And you have a 102. Now these look like they're tricky. Yes, they are. They want to escape. So I'm just going to splay out their legs a little bit. Keep them in place while I solder them up. Again, nothing too special here. This would make a really good beginner's kit, because there's not really too much scope to go wrong. But to be fair, we've done a lot of kits on this channel over the years. I've got a massive box of all the completed kits. It must be, God, I'm not going to say 100 in there, but it's a big pile. And I don't think we've ever come across anything that's been too tricky, really. We have here a 100 microfarad, so we have a 100 microfarad up there. Remember, long leg positive, and it's marked on the PCB which way round they should go. Then we have a 10 microfarad, again, long leg positive. Pop that in there. Are we really nearly done? I can't believe it. I honestly can't believe it. So I'm just splaying those legs slightly. So does anybody know what happens if you use an electrolytic capacitor backwards? My gut feeling is it should probably kinda still maybe work a bit, but I don't know. I'd have to really understand more about how the chemistry works. I think it's to do with ions, and they're moving from the positive to the negative, or there's something where they're actually moving the other way around in reality, but it's not important. There we go. Pop that in there. That's our connectors. So it gives us out, ground, 12 volts, ground. Out. Oh, I see. So the signal out should be common. I'm just eyeballing this because I think there's the output that goes to the headphones probably goes to that pad as well. So you can wire this into something. Maybe you could wire it into your hi-fi as one of those speaker test things, because do you remember when you'd set up your surround sound, you would always do that hissing, wouldn't it? Because hissing has multiple... Oh my gosh, what's this gunk? Something's not right. Something very sticky and melty was on the end of the solder there. So as I was saying, in your hi-fi you'd have something that would make all of these strange hissing sounds, which have multi-frequencies in it, so it allows you to hear all sorts of things, and that's why it's good as a test sound. Right, power. And here goes nothing. Hey! So that's serving as a volume. And you can hear that. It is literally the interaction of these transistors. And look at it go. I have a spectrum analyzer here running. Oop, stay on. And you can just about see, if I zoom in, you're getting quite a lot of action going on above the 100 Hertz area, and below 100 Hertz not so much. So if you are using this as a device to obtain your random number generator, you'd probably want to focus more on this end of the spectrum here. But it's pretty cool. I mean, I'm playing with this volume control. Now it's nice and quiet. And it remains pretty much consistent on there. And you can see as we add interference, it does affect the waveform slightly, but there you go. It does what it says on the tin, it generates white noise. You probably would though, let's turn it off. You probably would want to mount it in some sort of can though. It'd be interesting if that was in a totally sealed metal enclosure that was grounded. Then you truly would just be hearing what this circuit's doing without any outside interference. So you don't know at the moment if it's picking up radio or can be influenced like that. So if you had a radio transmitter, an RF transmitter, and you were belting it near here, you might see that affect that waveform that we were seeing on the graphics analyzer or spectrum analyzer. So hopefully that's of some use to you. I do believe I bought this kit on the eBay, and just look for white noise generator, and if we zoom in we can see it does say EQ kit SG10, so that's possibly an indication of who makes it. So good luck with that in your search to find one, and as ever, thank you for watching. Oh, before I go, I just thought of quite a legitimate use case for this. How about if you're suffering from tinnitus, that where you have a noise in your ears, right? Or a noise being generated by your hearing system that may not be a real noise, but you hear it, right? I do believe that there are things on the market to help drown that out. I don't know if they use tones or white noise or things like that, but perhaps you could use this. Although the 12 volts power supply might be a bit tricky.